Hi peeps, let's do some practice stoichiometry. This is with the combustion of propane. Propane is C3H8. So let's see. So natural gas is a fossil fuel that's composed of methane, which is CH4. Methane is often trapped in tiny little pockets of rocks, and we frack it. We capture it out of buried rocks. Methane's used in power plants to produce electricity, and when processing that methane, another gas is produced, and that called propane, and that's what I want to talk about. So propane is the fuel in the little white tanks in your backyard grill, and when we burn propane, we produce carbon dioxide and it enters the atmosphere. So here's the equation. Propane plus oxygen produces carbon dioxide and water. So this is a classic combustion reaction, right? Because there's the hydrocarbon fuel, there's the oxygen, and here are your two products, carbon dioxide and water. So before we can do any stoichiometry, we need a balanced equation first. So let's balance this thing. So 3 carbons on this side, but only 1 carbon on this side. So let's put a big 3 here and see if this works for us. 8 hydrogens on this side and 2 on this side. If I put a 4 here, this becomes 4 times 2, so that would be 8. So putting these 2 coefficients in, my carbon and hydrogen is now balanced. So let's look at the oxygen. So what do I have here? I now have 3 carbon dioxides, which means the oxygen is 3 times 2. So there's 6 oxygens here, and over here I have 4 times, remember this is a 1, so 4 times 1, there's 4 oxygens. So in total, right now, oxygen on this side, there's 6 plus 4, there's 10. There's 10 oxygens on this side right now. Can I make 10 on this side? Yeah. Just put a coefficient of a 5 here, right? That would be, because it's a multiplier, multiply the coefficient times this little subscript. So 5 times 2, so now there's 10. So now everybody's balanced. And the number that's technically here is a 1. I'm not writing it. You could write it if you want, but you don't have to write it. Okay, so let's look at our problem. It says about 200 grams of propane is needed to cook a meal on a grill. So the question is, how many grams of carbon dioxide will be produced if you burn 200 grams of propane? So this is a classic stoichiometry problem, and this is how you're going to set it up. And after you do this one, after you watch me do this one, there's another one you're going to do that's very similar, set up similar. So when you do any kind of conversion, remember you start with your given, and then you're going to multiply it by conversion factors in order to get the answer you want. And note, we're going to need 1, 2, 3 conversion factors here in order to get to the answer. And note how this is changing. We're starting with propane. We're given, right? We're being told that we have 200 grams of propane, but we want our answer to be in grams of carbon dioxide, right? This is the question that we're looking for, what we're trying to answer. So how do we get there? How do we go from grams of one substance to grams of another substance? And the key to this will be the mole ratio, because we know, here's our 2 substances. We know how these 2 substances are related. Every 1 mole of propane you start with, you'll produce 3 moles of carbon dioxide. So that's our mole ratio, 1 to 3. 1 to 3. For every 1 propane, you will produce 3 carbon dioxide molecules. 1 to 3. Okay. What's this? Molar mass. You remember that? Calculating molar mass. Let's do that real quick. Molar mass. Remember, molar mass is the mass of 1 mole of a substance. So let's do the molar mass of propane first. So Here's propane. Let's count it out. We have three carbons and 8 hydrogens. You're going to need to look on your periodic table. I already know. I don't need to look. Carbon has a mass of 12.011, each carbon molecule, and hydrogen has a mass of 1.01. I'm rounding. And if we do this math, this is 36.033. 8 times 1.01 is 8.08. So this is 44.113. And remember, what does this number mean? This means that if you had a mole of propane, it would have a mass, or weigh, you could say, it's not exactly correct, would have a mass of 44.113 grams. And because you know that these are related, you can set up conversion factors. You could put 1 mole of propane on top and 44.113 grams of propane on bottom, or you could flip it, right? Or you could put the grams on top. 113 grams of propane is the same as 1 mole of propane. Okay, so that's the molar mass of propane, and these are our 2 conversion factors. Let's do carbon dioxide real quick. Carbon dioxide, there's only 1 carbon in carbon dioxide. There's 2 oxygens. Remember, carbon weighs 12.011. Oxygen weighs 15.99. We could say 8. So this is 12.011, 31.996, 44.007. Look how similar these 2 numbers are. That's just random. So what does this number mean? Again, it means if you had a mole of carbon dioxide, it would have a mass of 44.007 grams. And again, we can set up, thanks to this equality, 1 mole of carbon dioxide is equal to 44 grams of carbon dioxide. Because of that equality, we can set up 2 different conversion factors. A mole of carbon dioxide has a mass of 44.007 grams, or flip it, it's the same thing, 44.007 grams of CO2 is the same as a mole of CO2. Notice, by the way, I didn't write the E here because that's the abbreviation for a mole. Not much of an abbreviation. All right, so we're going to need these molar masses, right? Here we're going to need the molar mass of propane, and here we're going to need the molar mass of carbon dioxide. So let's do the problem. So let's start with our given, and I'm going to start way over here on the edge so I have plenty of room. We're given 200 grams of propane, 200 grams of propane, and I'm going to multiply it. Whoops, sorry. Why did I put an equal sign there? That should be a multiplication plus sign. Sorry about that. And I'm going to multiply by 1, 2, 3. By 1, 2, 3 different conversion factors, but in order to get my answer, grams of carbon dioxide. And watch how these units are going to change. Okay. All right. So whatever you're starting with, whatever your given is, you need to put it down here in the denominator. See. And again, this is molar mass of the methane, of the propane. This is what I need here, 44.113 grams. So 1 mole of propane has a mass of 44.113 grams. So that's that. Now, if you notice, grams of propane will cancel, and now if I were to do the math, my answer would come out in moles of propane, but I don't want to do the math yet. I want to get rid of moles of propane. The mole ratio is the whole key to this problem. This mole ratio of 1 to 3 is what's going to enable us to switch from propane over to carbon dioxide, because we got to switch. We're talking about propane right now, but our answer eventually has to be talking about carbon dioxide. So watch what the mole ratio will do to us. For every 1 mole of propane, you will produce 3 moles of carbon dioxide. So that's the mole ratio. And look what just happened. We cancel out moles of propane, and if we were to do the math, our answer would be in moles of carbon dioxide. We don't want to do the math yet because we don't want moles of carbon dioxide. We want grams of carbon dioxide. So we need the molar mass of carbon dioxide now. So that's our other one we did. A mole of carbon dioxide weighs 44.007 grams. So which one of these conversion factors am I going to use? This one with grams on bottom or this one with grams on top? If you look at this, which one's going to work in here? I have moles of carbon dioxide up here in the numerator. I'm going to need it to be down here in the denominator in order for it to cancel, and I'm going to need grams of carbon dioxide to be up here in the numerator so that the final answer is grams of carbon dioxide. So because I need the units set like this, I can't use this one. This is moles over grams. I need this one, grams over moles. So 1 mole of carbon dioxide has a mass of 44.007 grams. Moles of carbon dioxide cancel, and the last unit standing is the unit I want. And now if you do all this math, if you take 200 times 1 times 3 times 44.007 divided by 44.113 divided by 1 divided by 1, you don't have to do that, your answer should come out to 598.56 grams. So there you have it. If you burn 200 grams of propane on your grill, you will produce almost 600 grams of carbon dioxide. And where's that carbon dioxide going when you produce it? It's going up into the atmosphere, right? It's a gas. It's just flying away up into the atmosphere. And what's it doing up in the atmosphere? It's trapping extra heat on this planet, warming us up. So, use your grill sparingly. All right, peeps, that's it. Email if you have questions.